Hey everyone. So that was an interesting chat before. So yes, this is talking about AWS, but the principles and everything I kind of talk about you can apply to any of the three CSPs. Thanks for the book plug as well. That does actually cover all three, and almost killed me to write. So if people get some value out of it, that'd be really good. All right, so I'm going to kick off, seeing as we're already a little bit behind schedule. So from 0 to 300 with Terraform Landing Zones. So this is pretty much how you scale a landing zone when you're talking enterprise scale. Like a startup should not have 300 accounts, project subscriptions in your CSP of choice. But at enterprises, this is the kind of scale you get to. And the fundamental thing to remember is you always need to build for day two. And this is something that I think gets missed, unfortunately, a fair bit of the time. And I had to learn this the hard way. So, landing zones, people may not be 100% across exactly what they are and all that kind of stuff. So I just thought I'd quick kind of primer for a landing zone. Effectively, it's building out your cloud platform slash cloud platforms. So all the teams that are using AWS, GCP, Azure in your company can move really fast. And they have this cognitive load taken off them. So generally, you'll see things like account vending, access provisioning, security guardrails, CI/CD, data backups, cost controls, all these kind of things centrally managed but offered as self-service to the rest of the business. And this is the story of how I went doing this at an energy company in the UK, and the lessons we kind of learned along the way doing all of that. So if you're ever doing a landing zone build out, the first little bit, the first, kind of going to the first 10 teams or so, it's really kind of easy. And especially if you're doing serverless first, which is what I strongly recommend, and I'll get into why in a second. But there's this interesting inflection point on the journey where you go through and your landing zone hits product market fit. And all of a sudden, everyone wants a piece. This landing zone that you were kind of having to push with people or develop collaboratively with teams, all of a sudden you've got teams banging on your door going, "Oh, we've heard it's awesome. How can we get on there?" And when you're building these out, you fundamentally have to do multi-account, multi-subscription, multi-project strategies. I think this has been something that everyone's kind of learned in the journey we've been on in cloud since 2006, I want to say. We figured out that when you need to split teams apart, it's operationally superior, it's more secure, and teams are able to move more autonomously. But there's a trade-off here. There's always a trade-off. Everything's a trade-off, right? So when you do this and all of a sudden you have many, many accounts, really you want to keep the platform team, the team that are managing your landing zone, you want to keep it the cost sublinear. So you don't want all of a sudden managing 10 if you scale your landing zone to 10 times the accounts, you don't want to have 10 times the amount of people required to look after it anymore. You're kind of chasing this sublinear scale factor. So can you keep it so when you actually go to 10 times the accounts, you've only have to increase the team by half, maybe? That starts to get a lot better. This is kind of like a key principle in site reliability engineering as well, is this concept of sublinear scale at platform. So the point, kind of the interesting point in the story and where we kind of figured out a lot of things and made a lot of mistakes along the way was we were at about 50 accounts. The client we were working with was like, okay, we're going to do a data center exit. So we're probably projecting we're going to need more than 500 accounts in this with about, a few months notice, like the data center exit's got to happen. You need to be ready. This kind of got to the point where, this has suddenly got a lot harder than it used to be. You've got a massive increase in expectations in terms of different teams, different architectures, different compute layers, and I'll get into that a little bit more. You have this problem where everyone's asking for things, so you focus on the people coming up, and everyone who's already on the platform, they've come to expect like a level of service. When you've only got like 10 consumers, it's very easy to keep them all happy. When you start talking to maybe you've got 50 or 100 consumers, the first 10 who kind of got accustomed to a certain level are going to get a bit like, well, where is it for us? And you have this fundamental problem with scale that if you break something, as more people use your platform, you break it for more people and it becomes a bigger thing. And it takes longer to fix because a lot of these fix ends up being, I don't want to say hacky, that's not the right word, but sometimes you're there having to kind of repeat the same process on many accounts, many projects, many subscriptions to get things back into a stable state. Now, that's, easier to do when it's 50 accounts than it is 500. And I'll talk through all the problems we hit. And then, the reality was we actually got our redemption arc on this. We started defining and measuring service level objectives. So we went from kind of a finger in the air, like people are happy, to go, no, let's go data driven. Let's figure out how we're going to do this. We did tech debt first prioritization, which is at an enterprise, it's almost heretical, but we built in this concept of, well, actually, we need to take care of ourselves before we take care of other people. Not that we can just ignore them, but we're trying to scale this platform out. We have to invest in new things and we have to potentially revisit old things. And I'm going to talk about the account vending machine kind of in a bit more detail about, well, actually, what we built isn't fit for purpose anymore because it scaled to a certain point and my God, is it starting to creak. And the last bit that we did was we started instrumenting the landing zone to make it observable. I'm a big observability person. I'll talk through kind of some ideas of how we started to do that and what that looked like. So the three key takeaways, and I will circle back to these at the end, is hope is not a strategy, another SREism, but data is power. If you are flying blind, if you don't know where you are, then every move you take is going to be a leap of faith at that point in time. Generally, when you start going into the cloud and you kind of get there, you get to the point where everyone's in charge of their own destiny, but very few people are in control. So that's something really big for us. And I think I just dropped out for a second. The second one is embed optionality into your Terraform. I'll get into what I mean by that quite specifically, but this is very much when you're starting to build out the Terraform and how you do state file management is really critical. And the last one is an observable landing zone is a scalable landing zone. So you need observability in order to be able to scale these things. All right, I'm going to very quickly gloss over who I am because I already got an intro. But I'm a distinguished technologist at Contino. Contino is a digital transformation consultancy. We're based in America, the UK, and Australia. As I said, I wrote a book. I was a HashiCorp ambassador last year. Alas, I had my first child at the start of this year, so didn't end up being able to make it back in, but I will be back in for next year. And I'm an AWS ambassador as well, but I do know I've done a lot on GCP and I've done stuff on Azure as well, so I can kind of talk to all three. If you're interested, questions on this, I feel like we're going to be running very close on time, so please reach out on Twitter and LinkedIn. Okay, platform team capacity. When you're looking at these platform teams and you want to get this sublinear scale, there's kind of two main dimensions by which your platform team capacity gets kind of challenged and constrained. One is the amount of services you offer, and the second is the amount of workloads you actually manage for other teams. So when we talk about services, and this is just looking at compute layer, there's a variety of different ways of looking at this, but this is kind of the easiest one, that when you look at serverless containers and virtual machines, the services you need to provide for teams to be able to operate autonomously in there and not be reinventing the wheel, it's quite different. Serverless is the easiest. Containers is not too bad, but generally you're adding Kubernetes into the mix. So, your mileage may vary there on how bad you think that is. And what we had in this journey was, well, we'd done serverless stuff. There's a bit of container stuff, but we're using ECS. So we'd kind of made it a bit easier for ourselves. But then all of a sudden we had all these VM workloads wanting to move because they were doing a data center exit. And all of a sudden we had to build all this, scheduling, some machine backups, the patching, Active Directory access. They needed Bastion hosts and antivirus and APM and all this kind of stuff. And my God, this was a big build out we all of it had to do. So this is kind of a thing when you're building a landing zone. If you can look after the serverless teams first, because they're the easiest, and kind of wait to mature a lot of stuff before you get to VMs. Don't start VM first. Please, please don't. The other way of looking at this capacity constraint is through modes of operation. So when you look at the workloads, that people are running, you ideally want DevOps teams where they build, they run it. And from a platform team, you kind of go, well, here's some base services and we've got the guardrails in place. You guys go for your life. You don't have this kind of expectation that we're going to do any operational workload for you beyond the services we provide, and we're not going to do that. But generally, at an enterprise, you end up with the other two flavors. So managed and operations in here, which is, the operations one is a bit more classical ITIL build and run style, where people build applications and they hand it to you to run because they don't have the capacity or capability to run it. Now, as you can imagine, the more of these you add along the way, that drains capacity. Like management of those applications and doing that properly takes time. And that's time in every sprint, in every iteration, however you look at it, that you can't spend on other things. And then you've got the fully managed solutions where people are asking for, one of the examples we had at this client was Tableau. They wanted us to install and manage Tableau because a business user wanted it, but there wasn't really a team for it to go to. So it ended up on us. That's quite a large capacity drain because that's quite a lot of overhead we've accepted. So when you're looking at these platform teams and landing zones, again, try and push serverless DevOps because you'll be able to support more teams for less effort. But the reality is you're going to have to do some of these other ones. And they're just, when you're trying for the sublinear scale, you need to be focused on trying to push teams in the direction you want them to go that allows you to service more teams, because that's how you kind of have success, is being able to support many teams, not support a few teams really well, but support a large amount of teams to a good level. Now, in this space, we started having capacity constraints because all of a sudden we had to do VMs, and I kind of showed how many different things we had to add. And all of a sudden we actually also had more managed and operations style applications as well. So what we found was, in two particular ways, our account vending and our access provisioning were really starting to fall apart. So, vending more AWS accounts and doing more access provisioning. Now, account vending, to go into that, that was the main one we targeted. That was the main one that people were complaining about. And what we found was that, people were used to getting, I want an account, they'd get it within a few days. Kind of a couple of days was pretty average. And all of a sudden it was going out to weeks, right? And this isn't the cloud promise of highly autonomous, highly moving teams. It's like, well, I asked for an account and now I've had to wait 2-3 weeks for it. Like, what's going on, guys? What's going on? And the way that we had things set up was our actual request for you want a new account is we actually had a YAML file that everyone on GitHub had write access, but not merge access to the repository. So if a consumer wanted a new account, you fill in the YAML file. We've got like kind of constraints around the format of that. You submit that to us. It'll do a Terraform plan, that kind of stuff. No ServiceNow, no Jira Service Desk, none of this nonsense in the middle, especially for these competent teams that have technical capability. They can raise a PR. And then you can have the Terraform plan. You can start to actually measure when someone's requested an account and actually not have this whole service now has to go to the team. They have to start messing around with it, whatever. But still, the central platform team does the merge to do account vends. And what we found was that actual Terraform apply for account vends, we could see the code build job time starting to expand. And it went from it would take roughly an hour to it was getting out to 8 hours on certain builds, depending on what was happening. It's like, well, how are you supposed to vend accounts quickly for people if it takes 8 hours for the apply to happen? Especially when we found that apply job was actually failing about half the time. And then you'd have to kick it off again, right? Now you can start to see why it was all of a sudden taking so long. So we attacked it with, okay, the lead time. We need to measure and track this. We need to understand where we're going at with this. I have a whole other talk that goes into this in a lot more depth because I don't have all that much time today, but around measuring and tracking, setting a service level objective around this for going, well, actually, from requesting an account, you'll get it within a day. And that's a performance metric that the team's going to be accountable for and we're going to own. And that's something that we need to be able to visualize. Now, I built out this kind of thing we call flight controller nowadays. Is coming out in open source. I'm not trying to sell you a product here. We want this to be open source. I want you to try and use it if you think it's useful. Again, if this is something you think you could use, please do reach out. I don't have time to go into full depth of it today. But on there, you can see at the top, we've got account vending, kind of an SLO up at the top, and then we've actually got cycle time. So the cycle time of how long it took to do the apply and that how often it broke were two things we know we need to have like diagnostic metrics here. So for the cycle time, what we actually did is we set a target. We want to get it under 30 minutes on average. And we actually re-architected all of it to AWS step functions. So we took from what was one big apply and a co-build job, and we actually had many co-build jobs parallelized out with step functions. I wouldn't recommend doing it on day one because it makes the debugging process harder. And as always, there's trade-offs. But we did do this big merge, this kind of re-architecture. And we were, I want to say, lucky. I don't want to say it's great with great forethought that we kind of came to we had the fact that every account was in its own separate state file. So then actually doing this re-architecture was quite simple, relatively simple. It would have been a lot harder. It had everything being in one giant Terraform state file, but instead we had many state files. And really when you get to Terraform state, it's much easier to merge it back if you decide that's what you want to do than split it later. I've been down this path a number of times. I hate splitting Terraform state files. Merging is trivial. So when you're looking at this, even if you have like all this stuff in a single repository, look at how you want to segment your state files out to give yourself options later to re-architect the way you're doing the apply. When you're doing application builds, it's a bit of a different kettle of fish, but when you're doing platform, many state files will give you a better option later. Because generally every account, every subscription, every project is a isolated unit that you can have a separate state file for. There's not really much value in having them all in one state file. And the other bit we did in here with the failure rate. So actually what we had was one repository that was doing account vending and access management at once, because when you think about it, you need to apply access to accounts. So they kind of have to live together. What we did in here was we figured it was better to degrade than to break. We'd rather have account vending happen even if something's going on with access management. And what it used to look like was this. We actually had Terraform apply that would go to AWS organizations and provision new accounts. It would also go to Active Directory to go and do wonderful things over there. Now, Active Directory wasn't something we managed, and the team managed it. But what we found was it was pretty unstable. The team working with it, they were trying to do quite a lot at the moment, and it would break quite continually. And there was also things about missing users and offboarding and just all this kind of stuff that just got really difficult. So what we found was if AD broke, the entire thing broke and accounts wouldn't get vended, and then we'd have to re-go through that apply process, which took an extended period of time. So we re-architected to actually split it into parallel jobs because both things need to happen, but they're not actually dependent on each other in a meaningful way, because the AD stuff was just moving people around into specific groups that then filtered through to SSO and did things. But these things were actually, although it made sense to put them in the same repository because they were intimately linked, but from an apply process, they had no actual technical dependency on each other. And what we ended up with, we could still vend accounts even if AD was on the threads. Really good thing to do. When you kind of get here is even you're in a single repository, because that makes a lot of sense in a landing zone for a lot of things, because it allows you to have that kind of YAML file interface for people. You still want independent deployments in here. If things don't have to be coupled, decouple them on deploy, so then you can actually still have like 80% of stuff applying, even if 20% of stuff is broken, and you can still get some things out while something else is broken. The next bit that we did was Terraform apply equals deployed, does not equal working. If anyone's ever looked at doing private DNS on AWS, it looks like this. It's pretty awful, to be honest. And what happens is you get this all up and working and you're fine. We, on a Friday night, me and one other guy, we thought we knew what we were doing. We actually ended up doing a Terraform change that redeployed all of this, all this section, this kind of centralized stuff, which broke all these associations because there's kind of a second bit that has to happen in the client account to make that happen. And what happens was we broke DNS for everyone on a Friday night. What looked innocuous, Terraform apply was happy. Everything applied. Like when you look at the build logs, everything is clean, but there was something we were missing in here. And when you're doing these landing zone build outs, you need to know where your failure is isolated to, so you can start to kind of narrow down on what it is that's actually broken in here. Now, in this instance, we actually broke the entire org, so that was kind of simple. But what we found was actually what we wanted to be able to do is go, is someone's got a failure of some kind of fashion? Is it just in one account? Is it a set of accounts? Is it accounts with a shared dependency? So in that Shared dependencies are classically like transit gateway or your shared VPC and GCP or some of your VNets, like depending on how you've done your network topologies and that kind of stuff. Generally, you have things pooling back to centralized networking resources. You want to be able to track which accounts are on that and then go, well, actually something looks like it's happened here because that's broken out, or an OU or a management group or a folder. Again, I'm trying to do all clouds here. And you want to figure this out. What we did is we actually deployed Lambda functions or Azure functions or cloud functions, whatever. They were actually doing a heartbeat every 5 minutes on the schedule that would do a private DNS lookup, a public DNS lookup. They would ping on-premise servers and they would ping public servers. And then they would put their results onto EventBridge that we just stored locally. Again, you can swap these services out. There's nothing area specific really here. But what this allowed us to do was kind of get that heartbeat coming back every 5 minutes, that if we broke DNS, we would know within 5 minutes and we know who'd been affected, which allows us to go to them first rather than them come to us with a problem. And if you've ever run like these internal services, it's so much easier to be able to go, we've broken something, we're fixing it, just so you know, you may not have been aware. That's a much nicer conversation to them coming, why have all my applications all of a sudden started failing because like DNS is broken? Like, what have you guys done, right? It's much easier to be on the front foot with this stuff. Okay, so coming back to, I talked about going from 50 to over 500. As of last time I checked with this client, because again, they're in the UK, I no longer am. I'm over here in Perth. They're at about 350. And I still talk to the product owner about new ideas and all that kind of stuff on a regular bit. We actually got up to 350. And the cool part was the team didn't have to grow to get here. We actually just kind of matured out and looked at things a bit better, and we actually got there. So rather than this whole of not 10 times the cost, not 1.5 times the cost, we actually did it with the same team just by kind of taking more data to it, thinking about things harder, and actually taking that time to mature our own stuff, investing in tech debt and rebuilding things, going, we don't need more people to hit buttons. What we need is more automation and building out things that are going to scale. Really, when I kind of said right at the start, always build for day 2. You're going to live with decisions a lot longer than it takes to make them. It's quite easy in a meeting to go, hey, we're going to do this. The reality is you're going to be living with that decision for 6, 12, 18, 24 months or however long. Please think about what the consequences of that decision are going to be rather than going, oh, this is easy. We've got DNS working. Well, how are you going to know that DNS is working? How are you going to know when it's broken? It's so much harder to think that way, but you need to do it. And I'm just going to finish up with the key takeaways. I've managed to carve some time back, which is awesome. So hope is not a strategy. Data is power. Please get this data, do observability, get all this data here. So when you're actually taking that next step, you know where you're going. The second one is embed optionality into your Terraform. That's very much this, think about how you want to do state files. You can always move Terraform around between files. The HCL is trivial, but the state files are kind of the key here. And make sure you actually split them up, because you can still apply them all together and kind of build something that applies all of them, but it gives you this option to spread, to move, to do all these things really simply. Like, it's an agile concept of, if you've got 2 choices and one of them is much easier to reverse than the other, go for the one that's easier to reverse. Because if you're wrong, you're not as screwed as if you go on the other one, you're like, oh God, we've put ourselves in the hole here. How are we going to get out? And the last one is concept of observable landing zones. It's not something I see talked about kind of ever, but in the reality is this is kind of the next step on top of a landing zone, is how do you actually operationalize it? How do you make sure you've got this under control? There's very much to be in control of your own destiny instead of just in charge of it. And really, it's observability. Like, go read all the Honeycomb stuff on observability. It's fantastic. They've got their book floating around, which is free if you can find it, kind of floating everywhere, the PDF. Go have a read. It'll change the way you think about things, and have a look at how you can apply it. And that's all I had. And I've actually managed to come back 1 minute under. So I'm quite happy with myself for that. And I apologize for talking fast. I always do.